And for this last example, we're asked that each digit can be repeated, but the first digit cannot be 0 or 1. Sorry, that is a typo. But the first digit cannot be 0 or 1. So if we come here and we calculate, first digit can be anything except for 0 or 1, which means that we have 8 possible choices for the first digit. And then after that, anything goes. And things can be repeated. So just like in the second example, we have 10 possibilities for the second, third, and fourth digit, which gives us a grand total of 8,000 different combinations of digits. And that leads us to the different types of probability. So the classical or theoretical probability is used when each outcome in a sample space is equally likely to occur. The classical probability for an event E is given by, it's a fraction, and it's going to be the total number of outcomes in E over the total number of outcomes in the sample space S. Right, and looking at the next example, you draw a card from a standard deck of playing cards, find the probability of each event. So probability of event D, we want to figure out selecting a 9 of clubs. And if you know your standard deck of cards, there's only one 9 of clubs out of all 52 cards. And if you toss that into a calculator, you get 0.019 rounded. So if we were to look at the probability of E, which is selecting a heart, there's 13 hearts, ace through king, out of the 52. That's going to reduce to 1/4, right? Because there's 4 suits. So this gives us an exact 0.25. And then this last example, the probability of F, which is selecting a diamond, a heart, a club, or a spade. Now there's 13 diamonds, 13 hearts, 13 clubs, and 13 spades. So altogether, there is 52 possible cards that satisfy that, or that are inside of the event F out of a total of 52 cards, and we get 1. So that brings up an important concept in probability theory, is that the 1 that you end up getting for certain probabilities should represent 100%. So this is saying the probability that you draw a card of one of these 4 suits is, you're drawing a card, so you will definitely draw either a diamond, heart, club, or spade. And probabilities can't be larger than 1 either, because it's a fraction. And since the event E is just some subset of the sample space, there's going to always be more things in the sample space than the set E, the event E. Our second definition of probability is what is called the empirical, or sometimes it's referred to as the statistical probability, and it's based on observations attained from probability experiments. So the empirical probability of an event E is the relative frequency of event E, which, if you recall relative frequency, that is just the frequency of E over the total frequency. Right, so in symbols, that's the frequency of E over the total number inside of that experiment, N. Right, so this example, you have a survey of 1,000 employees at a company, and you record the ages of each. The results are shown in the frequency distribution below. If you randomly select another employee, what is the probability that the employee will be between 25 and 34 years old? So we're looking for the probability that they're between 25 to 34 years old. And sometimes we'll use this where it's the probability of the thing we're looking for or sometimes we'll do the probability of the event if the event is listed out for us. So I may interchange the two notations. Looking at the chart, we see that ages 25 to 34, there are 366 employees, and out of the number of people surveyed, there was 1,000. And so if you randomly select one person out of the 1,000 employees, there's a probability of 0.366 that that person you selected is between the ages of 25 to 34. And as we talked about, the probability of an event E is always going to be less than 1. It can equal 1 if it's the whole sample space, but it's no smaller than 0, right? So 0 probability means that it will most likely never happen. A 1 means that it will most likely always happen. And anywhere in between just depends on if it's closer to 0 or to 1. So in symbols, it says that the probability of E is always less than or equal to 1, but always greater than or equal to 0.